Hello everybody, today we are going to be talking about the AP Chemistry 2019 FRQ number 1. This FRQ mainly deals with bonding and thermochemistry. In this FRQ we are asked about various intermolecular forces and thermochemical properties of urea. On this first question, we are asked to determine the hybridization of the carbon atom in the urea molecule. Remember that hybridization is the number of bonding sites. If you remember, carbon has 4 valence electrons and they are all being used up in bonds here, 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 and here. However, carbon really only has 3 bonding sites, the single bond on the right, the double bond on top, and the single bond on the left. Therefore, we can conclude that the hybridization of the carbon atom in this molecule is sp2. In part B, we are asked about the hydrogen bonding forces of urea. Remember that hydrogen bonding is the strongest intermolecular force and it occurs when hydrogen is bonded directly to nitrogen, oxygen, or fluorine. In urea, hydrogen is bonded directly to nitrogen, while in water, hydrogen is bonded directly to oxygen. So we can answer the question by connecting the hydrogen on the urea molecule to the oxygen on the water molecule with a dashed line. Part C is some simple stoichiometry. We start with our grams of urea and divide by the molar mass to get moles. We then divide that by the 5 milliliters you're given, convert it to liters to get our moles per liter, 17.9. This answer looks like a wall of text, but there are a few important parts with Le Chatelier's. Notice how I first answer the question, then I give my evidence, and finally I relate the evidence back to the given information. This reaction is endothermic because as temperature increases, the product increases, and according to Le Chatelier's principle, endothermic reactions favor products at higher temperatures. This question relies on your knowledge of the calorimetry equation Q equals mc delta T. We need to find Q and delta T, so make sure you mention the mass of the water, the urea, and the initial and final temperatures, and that's really all you need to answer this question. This question uses the summation equation, where the entropy change is equal to the sum of the entropy of the products minus the sum of the entropy of the reactants. This is easy because there's only one reactant and product, so when we set it up, we get this equation, and by solving, we get that 174.7 joules per mole is the entropy. As an AP chemistry student, you should know that solutions have more entropy than solids, but now you need to explain why. This is because there are more possible arrangements of the dissolved ions than there are of the solid urea by itself, and that's really all you need to say to ace this question. To complete this question, you need to think about Gibbs free energies. That is one way to relate entropy to reaction favorability. By using the equation delta G equals delta H minus T delta S, you can see that as temperature increases, T delta S becomes more negative, making Gibbs free energy more and more negative, increasing the forward reaction favorability, and that's really all you need to say when asked about reaction favorability. Congratulations, you've completed the first 2019 College Board FRQ for AP Chemistry. There will be more of these videos coming soon, and I hope they help you as much as this one hopefully did. Take care y'all, and I'll see y'all in the next video.